Hello group, Jeff here. I'm going to show a couple things today. One is with Siril and some of the newer features. And the second thing will be trying to pre and post process some really bad Bortle 9 data that I took. It was about 35 degrees up and sinking as I was grabbing the exposures. And the reason I did this is that I really can't shoot in my light dome because it's so inconsistent. It's not like I'm in the city. Uh, it's more of a nuisance than anything. So for the last few years, I've actually tried to stay away from that area of the sky. And based on some of my testing I did over the summer, I'm going to give her a shot again. And this is my first test with the C14. So let's get it going. I'm going to show you one more time, my Siril folder structure. And in my data drive, I have a Siril folder. And in this folder, I have a biases folder, a darks folder, a flats folder, and a lights folder. And I am pointing to this Siril folder as the working directory. Siril will make a process folder as it's running a script, or if you're doing the pre and post work manually. And in this is hundreds of files. I mean, lots and lots of files. So many, in fact, that you really have to be careful if you're close on storage. It's 55 gigabytes, 520 files. So I'm going to delete the process folder because you need to do this before each target. The scripts will break if you try to run with the last processed stuff in the folder. So I'm going to delete these. And then I'm going to also delete this results file, because the results file is what Siril creates after it does the pre and post processing and stacking. This is the linear data from that file. It's a 32-bit file from all the calibration frames and the lights. So I'll get rid of that. And you can tell by its size, it's almost 300 megabytes. It's a big file. And this was taken with the DS24C tech. So that's a full frame sensor. So what I want to do now is start Siril. And I will get rid of my puss so that I don't hide anything. And the first thing I want to do is run the script on all of the frames that I took that night in my Bortle 9 area. There's 90 of them. That represents an hour and a half worth of data. And we will see where it goes. Over the summer, I tried some things that I was reading up on, and some of the things talked about actually doing shorter exposures and more of them in light polluted areas. And the theory behind that is that you can control the sky glow better if you're taking shorter exposures. And I've tested that all summer with the Raza to some pretty good success. Now what I'm trying to zero in on is how much data I need to make it work. And I've kind of settled on between an hour and an hour and a half. I'm not going to be a guy that's going to take days or weeks worth of data and then process it for another week. That's not me. I like to shoot a lot of targets throughout the night, because life is too short to just do one. No offense to the guys that do. I just don't. That's a full-time job. It's not a hobby anymore. And the other thing that I started reading up on towards the end of my season, which is about now, is deep sky lucky imaging. And for those that are unfamiliar with the term lucky imaging, when you're shooting planets or even the moon, you want to take as many images as you can to try and beat the scene. And this could represent, in my case, when I shot Jupiter this year, I took 100,000 frames, but I got some great data out of it, great looking images, and I was able to make uh, a 5 and 15-minute rotation of the planet from all this data. So deep sky lucky imaging is taking that same premise, but with 5-second exposures and max gain on the camera. And saving the files to an SER animation. And that 5 seconds is an effort to beat the scene. So instead of getting, in my case, I've been shooting 60-second exposures. If I can get it down to 5, my chances of getting better scene in those 5 seconds is much better in with 60 seconds. It's a huge advantage. The only problem is you need to have a lot of data because you have to build the signal up over a lot of frames. So that's something that I think I can do in Mellencamp Sky, because Mellencamp Sky will let me embed the flat and the dark and save the files as a SER animation. And then I'll use Siril to process all that data. I'll start in pip, and then I'll go, I'll just keep it. I'll try my planetary workflow to get to Siril to see what happens. But that's a next year thing. And there's a lot of good information on the web for those that would like to try deep sky lucky imaging. You're going to have a lot of storage. So we're stacking now. And this data, we'll take a look at it here shortly, is really bad. I mean, there's horizontal banding from the sky glow, and because I started out high in the light dome and then worked my way down into the light dome, the frames later in the image build are worse. So that's why I'm using all of the data and not letting like the best 75%, because I just need as much as I can get. Now, that may be the incorrect thinking here, but this is just a test to see where it takes us. Okay, it took 4 minutes and 45 seconds to stack 90 frames. So now let's take a look at this. There's the new results file. And it's a linear file, you don't see much. So we'll use the histogram stretch. And I want to just take a look at all the channels. Here's some horizontal banding here. So what I want to do, I'm going to be a little more aggressive with the crop, because I know these areas are bad, so I'm just going to get rid of them. And now I'll do a background extraction, and I'm going to try a 2. We'll do the 20. I'll bring this down to, say, 40. See what we get. Looks pretty good. There's nothing in the targets, So I'll apply it. Looks like it's evened them out the best it could. You can see my hot spot right in here. I don't know if you can see my, we'll close this. Right in here is my hot spot. And this is where shorter exposures will keep that under control. This is what the data looks like, junk. So now let's start working on the color calibration. And because this data is so bad, I'm not even going to try to plate solve it. I'm just going to attempt to work on it this way. And we'll grab this. And we'll get rid of the green. That didn't do too much, did it? Maybe I have to get a better handle on. That's interesting. Oh, I know what's going on, Jeff. Sorry about that, people. I still had it in the histogram stretch. So let's do this. I will go back to the color calibration and grab that, neutralize it. There we go. Oops, still got to do this. Let's see what we look like now. Not bad. Okay, so I was able to clear up the 3 channels, but as you can see right in here, I hope that YouTube's compression doesn't hammer this, but there is still some horizontal banding. So what I'm going to do is go into this and bring the amount down a little bit and see if that clears it up. Yeah, it helped a little. Now I want to try a Meridian filter. Let's try 2. Now let's go back to the 2. That's better. Now you can really see the problems in the image from this light pollution. It just accumulates in the center so bad, and then around the edges. This has to do with dropping further down into it, and it's creating gradients that the background extraction has trouble with. But that's okay. So now I'm going to start stretching this puppy. After I do a color saturation, go to 32. We'll bring this down to 40. Might even go down lower. We'll do 32 because I really don't want the saturation to hit anything but the target. So let's do an ASIN transformation. I'll try 150 this time. We'll apply it. Let's try 56 and see what happens. We'll go with that. And what you want to watch is that as you crush, the reason why I like to use so much of the ASIN transformation is that it keeps the colors. It doesn't blow the colors out as bad as like a histogram transformation will. If you start stretching with the histogram transformation, you're going to start blowing stuff out. So I want to go as far as I can with the ASIN, or whatever you want to call it. One of these days I'll learn how to say it. Let's see what we did. We're still good. Do another one. '96. We'll just check. We're still good. And now I think I've gone as far as I want to go with the ASIN transformation, and I'm going to start stretching with this and see what we have. And you want to watch your clip here. When this number hits 0.1, you've gone too far. So I'm going to back off just a tickle. We'll apply that. You can see there's a lot of noise in there. I like to try to keep it as close as I can in the beginning here. We'll apply this. We'll just do another little one. Let's see what we can get. We'll apply this. We'll apply this. Maybe do one more. Histogram is stretching out nice. And you can see I'm starting to climb the wall here, so I'm probably going as far as I want to go. So we'll apply this, close, and then I'll save the TIFF as a test. And what I want to show you now, because I believe that we have enough of we have an image that's as good as I can probably get it here. I want to go in and plate solve this. And we know that it is NGC 7319. We won't flip it, we'll just plate solve it. Oops. We'll do this in bad. And what we want to see is if it plate solves, these two will unhighlight or unghost. Oh, shoot. Let's try this one. Well, maybe I do have to flip it. Yeah, it's not going to go. Son of a gun. Yeah, it's found stars. It's just having trouble lining them up. So let's try 67 and see if that works. Sometimes if you play with your numbers, your focal length, it will, you can fool it into plate solving. But it doesn't look like today is that day. So what I will do is save this, which I did already. I will open up a light from the same group of images. I will debayer that light and I will stretch it. And what we will see is you'll see all my boogers, booger, 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 vignette, vignette, and the target. It's right there. You can see that I have a huge glow in the center. And what I want to do now is hit Control F6. Oops. There we go. Get it right, Jeff. And the dynamic PSF window opens. And what this will do, or with this window, you can do a sensor tilt analysis. So I will press this, and you can only do this on subs. You can't do it on a stacked image. A stacked image averages out all the frames, and you don't want that. You want an unaveraged or untouched sub. And what this will bring up is a square. This square represents 4 quadrants of the image that the software has determined the PSF values of those 4 quadrants. So you have your center, top left, top right, bottom left. And that gives you the tilt of your sensor. What you want is all these numbers to be as close as you can get them for a flat sensor. And it exaggerates the box so that you can see where your worst tilt is. So next spring, Jeff has a nice little job to do to get the C14 and the Moonlight focuser adjusted up so that I can get rid of my sensor tilt. I've had, in the 7 to 10 years I've had the Moonlight focuser, I've had it on and off numerous times, and I'm sure that in those times I've probably done something to the adjustment. And I also have a very rough driveway, so that doesn't help. But this is not bad for how rough my driveway is. I'll take this any day of the week. But I can get it out because the Moonlight Focuser has an adjuster. I did my Raza, and the Raza is off less than the C14, but I can't adjust the Raza. The only way for me to adjust the Raza's tilt is to get a apparatus that you attach your camera to, from Octopi Astro. This is the device. It attaches to it replaces the Raza adapter that you get with their adapter. And the camera fits in this piece here. The camera can go left, right, up, and down. And then you can adjust the tilt and back focus with this device. And this is what I need. It's not cheap, but that's the only thing I've found so far that will let me take the sensor tilt out of a Raza. And apparently, this is a common problem because he wouldn't have had to make one of these if he wasn't getting asked about it. So this will probably be my next project, is getting something for the Raza to take my sensor tilt out. And let me go to the Siril website. Post Siril. And we'll go down towards the bottom. And it has an explanation of the sensor tilt. And you can see how this guy's a little worse off than I am. But one of the features that they have now is they have pixel math. And I really don't know that much about it. Seems more sciencey than anything, but you can use pixel math to process your images. So that's there if you're interested. And I will now go back to here, and because I have this image, I can plate solve on this. Because it's an untouched image. We'll see what happens here. It looks like it's found it. And you can see right here, those are now unghosted. So if I click on it, you'll see that it will tell you, this is very similar to what astrometry.net does. And the other thing you can do is put the celestial grid up. There's north is pointing down, east is to the left. You can change by hitting Control P. You can change where you place this. So I'll just go to the other side. Bottom left, apply, and boom, there it is. So I'm going to put it back to where it was. Apply. And the other cool thing is if you know the magnitude of a star, say this one here, I will click on this. And you know the magnitude to be 13.9, not 14.9. You can do a, what's it called? It's called, bear with me here. Set mag. Because you have that star selected, you can do a command line set mag right here. Let's just try it. Set mag. minus 13 and see what happens. And there it is, minus 13. So that adjusts all of the stars to their correct value based on the star that you knew of a known value, which is kind of cool. I like that. I'm always wondering what magnitudes these stars are at because I don't always have a planetarium map. But if I know the star, then I can actually set the magnitude of the star on the selection. And when you type in set mag and the magnitude, it will adjust every star based on this uh, new magnitude that you gave it. So that's some of the features in Siril. What we'll do now is open up Photoshop and see how we can do processing, post-processing. I have to really be careful with, because the background is so ratty with this image, that I'm going to be not quite as delicate with, or I'm going to be very delicate with the denoise. I will do some, but not anywhere near. So the first thing I'm going to do is my astroflats, and this will even it out the best that it can. We'll take this. Then we will go and do a little denoise. Excuse me. And I'll zoom out here so you can see what I'm talking about because it's got like a mottled background already. The denoise is going to give it just a little bit more, but it will help me select the stars. And you can see right through here, it's got some modeling going on right there, but that's okay. Because once I get the stars out of here, then I can start playing. I'm just going to try one thing real quick here, and that is an auto color. Yeah, let's do that. Now I will go and do a duplicate and another one. And I will run my star terminator. And I want you guys to pay attention to how these look right now. Because when I'm done, hopefully they'll sharpen up. Oops. Hit okay, Jeff. Removing the stars from a background is a godsend. And I think what I'll do is just disappear and come back when we're closer towards the end of the star removal. So we'll see you in a bit. Okay, we're back. We're almost done removing the stars from the background, and it actually did a decent job. What happens with any star removal program, the worse the background is, the harder time it has distinguishing between some of the smaller stars and the noise that's in the image, but that's okay. We can work with this. So I want to add another layer, call it Starless. This layer below it, I'm going to subtract, merge it down, move it up, change the mode, and now we got our stars back. Okay, so what I want to do now is duplicate this layer and call it camera, and go into camera. I don't want to go too high here. Maybe. Just blacken this up a little more. Go something like this. Okay, so now I'm going to start adding some texture, some clarity, some dehaze, some vibrance, a little saturation. And to sharpen things back up, I'm going to go and really give me some sharpen. So we'll do 40. See what happens there. Then we'll add some noise reduction. We got some pretty nice color out of that. Let's take this before, after. Let me take the stars down. I prefer to look at the target. As much as I like stars, the colors, I don't like them in my face. So now this is a better representation of the target, because that's why we shot this area. Not so much the stars. The stars have the correct colors, but by scaling back on the stars, we change the focus to the target. So we went from this to this, from this to this, from this to this. Now, is this APOD worthy? I don't think so. But to actually get some usable data out of my Bortle 9 34-degree up skies and sinking as I was taking more exposures, I'll take this any day. There's some cool detail that I have never seen, like this and this, all this interaction. Some cool stuff. And you got 3 little stars inside there. It looks like a UFO, for Pete's sakes. So I'm very happy with this little test. As you can see, it's not perfect by any means, but it's also not. It's also something that isn't worth throwing the data out. There was something there that I could pull out. It took some finessing, and some of this finessing, I hope you can use with some of your poorer data. And the other thing that I hope you picked up is some of the tools that are now in Siril are really kind of cool. That program, the more I use it, the more I like it. It has really changed how I process images, and I'm loving that 16-bit to 32-bit workflow. Unfortunately, Photoshop is still a 16-bit app, so to speak. You can do stuff in 32-bit, but my problem is that going from Siril to Photoshop with their 32-bit saves isn't working very well. So I have to figure a way around that to keep the files at 32-bit. That just gives you so much more dynamic range to play with when you're processing, post-processing, doing it. Just the whole workflow, it just makes life so much easier. So I hope you guys and gals get something out of these videos. I enjoy doing them. I'm not going to live forever, so I'm passing it on before I go. We'll see you in the group. Thanks for watching.